So surface area of solids. Surface area of solids. 10 minutes notes. Put off, Rios, thank you. Surface area of solids. Phones away, Ramirez. Let's do this. It's only 10 minutes. That's all I ask. 2 computers, what's that all about? Oh, gotcha. All right. Just give me one light. What the heck is a solid? I'll tell you what a solid is. I got a bunch of them in my hand right here. Look at it. I got a yellow cube. That's a solid. I got a pentagonal prism. That's a solid. I got a cylinder in my hand, Anaya. That's a solid. All it is this. Write this down. Any three-dimensional object. Any three-dimensional. Look at 3D. Length, width, and it's coming out at you. It's 3D. So go and write that down. Any three-dimensional object. (3D). Hurtado, you with me? Any three-dimensional object. What do I mean by that? Let me draw a picture of a 3D object. Now to draw this, just draw the trapezoid in the front. Look at the front trapezoid. Look at that. And then just extend each corner. And then draw like some dotted lines to give it a 3D effect. Notice. Let me do that again. I draw the front trapezoid. And then at every corner, see every corner, look at these corners. I'll just extend it. Look at it. And it becomes 3D. Little technique. Go ahead and draw yourself a trapezoidal prism. If that's Mr. Urabi, we're going to take a 5-minute break just so you can present something. Give me the... It's right there, left right there. Got you. All right, solid, anything 3D, as opposed to last week was 2-dimensional, flat surface. Remember, it's just flat stuff? Like, look at look at this cube right here. Take this out. This cube, if I make it flat, now it's just 2D, length and width only. But now, if I fold it in upon itself, 3D, length, width, and now it's depth, thickness. So any three-dimensional object is a solid. Next word, watch this. Surface area. Surface area, write that down. Second word, we're going to do 3 words today. The area of all the faces of a solid. The area of all the faces of a solid. The area of all the faces of a solid. Phone's away right now, either, right? Let's do this. The area of all the faces of a solid. Faces? What the heck is faces? Where does the word face come in? What the heck is a face? Well, look at that prism you just drew a little while ago. Every shape is a face. So look at right here. I outlined a trapezoid and I outlined the rectangle. Those are called faces. Go to write a face. The rectangle and the trapezoid are a face. And I'm saying, look, the surface area is the area of all the faces of a solid. How many faces make up that solid that you and I just drew a little while ago? How many faces make that up? 6 faces. Go to write 6 faces. There's 2 trapezoids, 1 trapezoid in the front, 1 in the back. That's 2. I got 2 rectangles on the left and right. That's 4. And I got 2 rectangles at the bottom and top. That's 6. 6 faces. So I'm saying, look, at the surface area, if I want the surface area of a solid, It's the area of all the faces. This one has 6. Get that phone real quick here. Watch this, Anaya. This has 6 faces. Look at this one right here. Look at this. Let me open this puppy up. How many faces does this one have? Watch this. If I open it up, there's a pentagon face, second pentagon face, and how many rectangles here? 5 rectangles. So we got 5 rectangles here, and then 2 pentagons on the top and bottom. So that's a total of 7 faces, this one. Okay? 7 faces. How about this one? I forget that one. Look at the cylinder. If I open up the cylinder. If I open it up, that's one face, the circle. Second circle. And look, it's just one big rectangle. You see that? One big rectangle there. And we're going to talk more about this one tomorrow. We got the one big rectangle. They got the circular face on top and bottom. Thank you, Miss Diane. So that's all a face means. Okay? Faces, 6 faces. We got the surface area. What would be the surface area of this cube then? Don't draw this because it'll take too long. How many faces make up a Rubik's Cube? Let's see, top, bottom, left, right, front, back. How many faces here? Well, my question is this. How many faces make up the cube, the Rubik's Cube? How many faces? It's like this, right? Look at it. How many faces make that up? There's 6 faces. If I want the surface area of this Rubik's Cube, I figure out the area of all 6 faces. And I think Clemente is already on that. She's looking at this face. Look at the side face. I'll highlight in blue, right here. What's the area of that one? You can see it. Look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. Huh? Look at it. That side face is 9 square units. Look at that side face. How many faces are like that in the whole thing? This face is 9 square units, so if I want the surface area of everything, just multiply that puppy by what? 6 of them. There's 6 faces. Every face is 9 square units, and there's 6 of them, so 9 times 6 is 54 square units. The whole I'm going to put SA for surface area. I found the area of one face. Since they're all the same, I took the area of one face and multiplied by 6 because there's 6 faces. So the total surface area is 54 square units. That's how many square units cover the Rubik's Cube. Okay, you don't have to write this down. If you do, that's fine. But do write the definition down because we're going to come back to this right now. Right now, I want to get conceptually in your mind what surface area means. It's the area of every face added up. Last word, watch. Stay with me, Rios. Here we go. A prism. What the heck is a prism? Check this out. There used to be a car by Chevrolet, a Geo Prism. Have you seen one? Last word, Martinez. A prism is a solid with 2 exact faces opposite each other called bases. Last word of the day. Write that down. A solid, you already know what a solid is, 3-dimensional shape, with 2 exact faces opposite each other called bases. A solid with 2 exact faces opposite each other called bases. All right, watch this. A solid with two exact faces opposite each other called bases. Let me show you one. Let me show you a prism. This blue one was a prism. We call this a pentagonal prism because you have a face on the front and the back. Look at, they're opposite each other. Opposite each other. I got a pentagon in the front and pentagon in the back, opposite sides. Prism. Look at this one. Purple. Toscano. I got a rectangle in the front and the same rectangle in the back, opposite each other, so we call this a prism. Here's another prism. I got a hexagon in the front, and on the opposite end, there's another hexagon, front and back. So as long as two faces are the same or in the opposite each other, we call it a prism. And here's a square prism, which would be called a cube, but it's still a type of prism because you have one face on the front, and on the other end, the same face. Prism. That's all it is. Let's draw a triangular prism, since you know what a prism is now. Watch. Go ahead and draw a triangle with me. Let's draw a triangle. And then on every corner, let's extend it. Watch. Look at this corner, the three corners. Extend it. If you make a dotted line, it gives it a 3D effect. Look at. Now it's a triangular prism. You have a triangle in the front and the back that are the same. So I'm going to write triangular prism. I name it by its main front and back face. Triangular prism. You with me, Ortiz? So far, so good. Triangular prism. I'll do that again. I'll draw it again for those of you who are artistically challenged. It's okay to be artistically challenged. It's going to be all right. Triangle. Look at front face. Now I'm going to extend from every corner. Look at, boom, boom. Make that one 3D by putting some dotted lines. Look at, boom. Look at the front triangle and the back triangle are exactly the same. That's what makes it a prism. Triangular prism. On your notes, go ahead and put an arrow in the front towards the front face, an arrow in the back face, and put two faces exactly alike at opposite ends. There's a triangle in the front end, triangle in the back end. They're at opposite ends. That's what makes it a prism. Okay? World of prisms. Sorry. That's it. Let's draw one more. Let's draw a rectangular prism. I'll do it in blue. Watch this, a rectangular prism. Kind of like my purple one right here. I'll draw a rectangle in the front, a rectangle in the back. Watch. Draw a rectangle with me. Let's make this, let's say, 10 inches, and this is 5 inches. Rectangle. Thank you, Taide. Draw me a rectangle. Now look at every corner, Reyes. Watch this. Every corner, I'll extend it, and then make the other same rectangle in the back. Look at. I'll put some dotted lines to give it a 3D effect. Sure. So now we got a rectangular prism. Because the front and back face are rectangles, as opposed to the front and back faces being triangles. Triangular prism. And going to write rectangular prism. Right, Villatoro? Triangular prism, rectangular prism. So far, so good. You guys are doing excellent for a Monday, I must say. Notice how the front rectangle and the back rectangle are exactly alike. That's what makes a prism a prism. Questions so far? So we've defined 3 words. A solid, that's just anything that's 3-dimensional. Surface area, find the area of every face and add them all up. And now a prism. Now we're going to bring all 3 words together with one example, and we're done with our notes. Okay, watch this. One example. All right, example 1. Find the surface area. I trust you can draw that prism. See if you can do it. Right, it's example 1 now. Officially example. We're going to only do one example when we're done with our notes. We're going to do this one example, and that's it. Find the surface area. Copy that down. And give me the dimensions, 12, 8, and 7. Give me the dimensions too, 12, 8, and 7. Got it, Hurtado? Nice. 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 Did you get it? Nice. Cool, cool, cool. All right. Here we go. Here we go, here we go. How many faces make this up? Someone besides Clemente. How many faces make this up? 6 faces. I got top face, look at this, and the bottom face in blue. They're exactly the same. Look at this. Not only that, I got the right face. Look at this right rectangle here. It's 12 by 8, actually 12 by 7. And the other on the one on the left here, look at this. That's a 12 by 7 rectangle on the left and right. They're the same. And then we got the front and back, right? The front face, it's a rectangle. It's 12 by 8 here. The front rectangle and the back rectangle are exactly the same, which is a total of 6. If I'm going to find the surface area, you just wrote down about 5 minutes ago, surface area means the area of all the faces. All they are rectangles. You know how to find the area of a rectangle. What's that formula? Do you guys memorize the area of a rectangle formula? Area of a rectangle is from your reference sheet. You should memorize it though. Length times width. From your reference sheet if you forgot. It seems like you did forget. Shame on you. Length times width. So I'm going to find the length times width of every rectangle. But there's a shortcut because 3 pairs are the same. Top and bottom in blue, they're the same. Left and right in green, same. Front and back, they're the same. Let's do 2 at a time. Watch. With my blue marker, I'm going to write top and bottom. Top and bottom face, they're the same. So I'm going to find the area of one of them and multiply it by 2. Look at the top face in blue, bottom face in blue. They're the same face. So I just got to find the area of one of them and multiply by 2. The area of a rectangle, like Mr. Atayda said, is length times width. Write that down with me. All right, Ramirez? Okay, let's see. What is the length and width of that top rectangle in blue? Ortiz, what would be the length and width of that top rectangle? What would be the length? How about that? Good. Length would be the longer side, so the width would be 7. 8 would be the length. So here we go. 8 times 7. Very good. That was easy. 8 times 7. Help. 8 times 7. Thank you. Chickens, horses, or termites? What kind of feet? It's area, huh? So it's square feet. Put square feet here. Thank you, Toscano. Thank you. The area is 56 square feet. That's the area of one face, the top one. But isn't there another face that's the same? What face is the same as the top? The bottom. So why don't we just multiply 56 by 2, and we'll get the top and bottom area. That makes sense to me. I'm not sure if it does to you. 56 square feet is the top. There's 2 of them. So multiply by 2 to get the total area of the top and bottom. That's going to be 1, thank you, square feet. All right, we're done with the top and bottom. I'll leave that there. So far, so good. All right, in green now, I'm going to do the left and right. Watch. We're almost done. In green, I'm doing left and right. Going to write left and right. Okay. In green, I'm doing the left and right area now. Look at the left and right rectangles. Again, the area of a rectangle. Anaya, what was the area of a rectangle again? The formula? Define the area of a... Nice. Here we go. I'm going to write it down just to remind myself. And now I'm going to start plugging and chugging. Here we go. So look at that side rectangle. Do the one on the right. It doesn't matter which one, the right or left. But look at this one on the right. Look at that rectangle. I need the length and the width. Help. Length is 12. What's the width of that side rectangle, Martinez? So look at this green one right here. Length is 12. What would the width be? Let the guy talk, Toscano. So Clemente said the length is 12. Look at the width. You said 8? So right from here to here, look at, is that 8? That's the question. Look at right here, from here to here. Is that 8? Someone help Martinez. It'd be 7, huh? It's the same as this side. It's 7, look at. So that's 12 times 7 would be the rectangle on the side. The length would be 12, the width would be 7. Write that down. You admit either. You're lying. What's 12 times 7? Chickens, horses, or termites? What kind of feet? Thank you. How many rectangles are like that? There's 2. There's one on the right. Look at the other one on the left is exactly the same. So I'm going to multiply 84 times 2. Right, Ortiz? Let's see, 84 times 2 on my calc. Let's see. Nice. Square feet. Nice. So notice what we got so far. In blue, we got the top and bottom. In green, we got the left and right rectangles. And now we just need the front and back rectangles that I highlighted in red. And we'll have the surface area. With me, Razo? Yeah. Watch this. Look at front, right there. The length and width of that front rectangle. Here we go. So I'm going to put front and back here in red. Here we go. Go to write front and back. Front and back. Top, bottom, left, right, front and back. So I color coded mine blue, green, and now red. Area formula for a rectangle, Lopez, is what? Thank you. I'm going to write it down just to remind myself. That's the area of a rectangle. Let's rock and roll. Area then of the front rectangle. What would be the length of that front rectangle, Ramirez? That one in red. What's the length of that one? It's right here, this one in red. What would be the length right here? Ramirez? Can you just tell me the length of that front rectangle? From here to here? Roz will help him out. 12 feet. I'm going to put it right here. And Cisneros, what's the width of that front rectangle? Nice. Look at here. This one's now, this is the width here of the front rectangle. It's going to be 8. So 12 times 8. Rocking and rolling. I never memorized my 12s. So 12 times 8, 96. You with me, Anaya? Let's see, 96 square feet. That's only one of them, though. Let's not get all happy. We got to get both, the front and the back. Nice. We're going to multiply that by 2. 192 square feet is my area. Okay, that's the front and back. In green, I got the left and right, and in blue, I got the top and bottom. So the total surface area of the prism, kind of looks like my purple one here, the total surface area is all of it together, all added up, all the square units together. So I'm going to add them all up. So I got, let's see. So I'm going to put SA for surface area. SA. SA means surface area. Here we go. 112 plus 168 plus 192. Now we'll have our surface area. I got top and bottom, front and back, left and right, all added up. I want to say it is 472. Sounds good to me. I think you got it. Nice. 472 what, though, Toscano? What happened? Nice. Here's our surface area. I'll put SA, not A. SA, surface area. We're three-dimensional now, not just A. SA. All right.